All right, some AP review problems. Short and simple, more on the multiple choice side. Pause the video, give them a shot. I'm just going to do them right out as fast as I can. First one here is take the derivative of this function. It is a product rule, f, g, so 2x times e to the cosine 4x, that's the easy one, plus x squared times, now the derivative of e to the cosine 4x is e to the cosine 4x, and I will do it this way. I'll write d dx then of cosine 4x. Now I'm going to do two steps. So if I move my big limit to infinity down, so my final answer here is 2x times e to the cosine 4x plus x squared times e to the cosine 4x times derivative of cosine is negative sine 4x times 4. So again, you can simplify it, but it's just a product rule. All right? A bunch of ways to do it, but that's the answer. Next one, find the limit as x approaches positive infinity of the following function. And after we do positive infinity, we should probably talk about negative infinity. We can just change the sign. We realize, we look at this and we recognize it as a rational function, right? Top and bottom. We have rules about rational functions. If we look at the highest order on the top and bottom, and if you distribute the 3x, you guys agree the highest order on top is negative 27x cubed. X cubed is the highest order. What's the highest order on the bottom? 4x cubed. So the answer to this, as it goes to positive infinity, is all the other things would go away. Because if I want to do the rule, I can multiply by 1 over x cubed on top and bottom. All right? And maybe I should do this out so you guys can see it. But the truth is, right now, you should be able to see that the answer is negative 27 fourths. That's the answer. Okay? If you multiply this disaster out, just to prove it, okay, I get 18x minus 12x squared minus 27x cubed. I'm going to leave space, and you'll see why in a second, over 4x cubed, negative 28x, negative 3x squared, plus 21. All right. I can multiply top and bottom as long as I do the same thing. So I'm going to multiply everything by x cubed. 1 over x cubed, I'm sorry. And when I do that, this is what it'll look like. And you guys can agree, because I did it to top and bottom, it's legal. These cancel. Remember, we have a rule, limit, as x approaches infinity, of 1 over x to the n power is always going to equal 0. So all of these other ones go to 0 that I'm striking out in blue. So we've got x on the bottom, 18 over x cubed, 0. 12 over x, 0. This is negative 27. Negative 3 over x, 0. Okay? Then you're left with negative 27 fourths. Now, this is the reason this works. All right? The question I said before we started this problem is, what happens if I make this negative infinity? All right, it's x cubed over x cubed, right? Negative over negative is still positive, so it's still going to stay the same. Okay? Still going to stay the same this time. All right, next problem I want you to try. Show that the mean value theorem works on the following function. All right, this says the mean value theorem. I'm actually going to take a second to explain this. You should have memorized probably this, right? That the rate of change, the instantaneous rate of change, is equal to the average rate of change. Okay, the instantaneous rate of change is equal to the average rate of change at some magic point C between A and B. To put in context for the problem on the board, I could do a graph on my calculator, or remembering the good old days, plus 4 minus 4, I could graph the parabola. All right, and again, I can complete the square probably faster than you guys can. This graph was 2 over and 3 down, and at 0 it had an intersection of 1, so it looks something like this. All right, from 0 to 4, 3. If I plug in 4, I get 16 minus 6. I get 1 over here too at 4. So there's 4. All right, and it's saying, first of all, I sure hope you guys found it. It doesn't change colors. Unless you change there. I sure hope that it's 0. The average rate of change better be 0 when you plug it in, because on my graph I see it. So f of 4 minus f of 0 over 4 minus 0. I'm not even going to do it. I'm going to assume my graph is correct. You guys are saying it's correct. I'm not even going to plug it in. It's 0. So then I get f prime of c, some place. Well, based on my graph, where does c have to be? I think it's got to be at the vertex, yeah, at the bottom. It has to be here at the vertex of the, it's got to be at 2, yeah, it's got to be at x equals 2. C has to be 2, so it just better work. My f prime, so I can do this here, is 2x minus 4, you guys agree? So 2x minus 4 equals 0. I can stop here, x is 2. You could have done the mean value theorem on this problem graphically this time. All right, mean value theorem again, and it's an important deal for us to understand on these bigger problems we're going for the AP. So 3 review problems, I think that's it. I'm going to check the next page. Oh, no, one more. I want you to draw a differential field of this differential function. And actually, maybe what we'll do is I'll give you an initial condition here, and we will integrate this function secondly. Okay, so 2 more problems. All right, so a slope field. I'm going to start with 0, 0. Because if I plug 0, 0, and I can immediately see that when y is 0, I'm going to have a slope of 0. So all of these points across the x-axis are going to have a slope of 0. So I'll just draw in a slope of 0 line. I also know that when x is equal to 1, you guys see that if I make x equal to 1, all those slopes will be 0. If you're going to do these type of problems on the AP quickly and efficiently, you have to find those 2 zeros pretty quickly. You guys see why those 10 values out of the 25 you have to calculate took 2 seconds? All right. Now it gets no fun. The only other thing that's a little easy is what if y is 1? If y is 1, it's just the value of the 1 minus x. So if I look at y equals 1 line across, I just got to go 1 minus x. So right here at this point, 1 minus a minus 2 is 3. So the slope here is 3, which is about that steep. 1 minus minus 1, the slope is positive 2. 1 minus 0, the slope is 1. That should be a 45-degree line at that point. Over here, 1 minus 1 is going to be 0, right? Actually, that's another thing I can do. Every time there's 1, I can put 0. I got all these zeros I forgot. No, that's 2. What am I doing? Those are all wrong. When I put in 2, that was wrong at that point. 1 minus 2 is negative 1. It has to be 45 down. Does that look better? All right. Now, I don't think there's anything fun for the rest of the points. I think you've got to just plug and chug. I'll plug in point 2, 2. This point right here, 2, 2. 1 minus 2 is negative 1 times 2 is negative 2. So it's steeper than this, down. There, negative 2 slope. I will plug in this point, negative 1, 2. I get 2 times 2. I get a positive slope of 4. Holy cow, that is steep. Over at this point, I plug in negative 2. I get 3. I get a positive slope of 6. It has to be steeper yet. It's kind of hard to do. There we go. Down in this quadrant, I will do these 2 points. I'll start with this one. 2, negative 1. 1 minus 2 is negative 1 times negative 1 is positive 1. So again, a 45 slope. This point, 2, again, for x makes negative 1 in this part, times 2 is negative, or times negative 2 makes, wait a minute, yeah, makes positive 2, so again, it's sloping up positive 2, it has to be steeper. I don't know. I got to think about it. So now, in quadrant 3, yeah, because the only change is that, I see what you're saying, the change in value is just the sign in y, right? Because the x stays the same, so this portion of the product stays the same. All you're doing is switching the sign, so yeah, these all are negative slopes. So, there we go. That is the, yep, there's the slope field, they're mirrored across. Yes. This is, Easy points. You guys is yes. Now the other thing in AP, what if I tell you the initial condition of this is when f of 0, when there's f of 0, it equals, say, 2. We should be able to, yeah, so we know, all right, we know, I missed a point here, didn't I? Right here. I plug in 0, I get 1, 2, there it is. So listen, we should be able to find the function based on this thing. Now again, if I have a derivative and I tell you I want the function, what do we have to do? Integrate. I want you to integrate this differential. Well, I gave you the value so you don't have to leave plus c. I want you to figure it out. All right? If you need help here, I'll pause it. We'll get started. How about that? So listen, first thing is, do you guys agree we have differentials here? The first thing you always have to do in these cases is we have to separate. I'm going to multiply by dx. And I can't integrate y with respect to dx on this side, so I'm going to divide by y. Well, here we go. I have 1 over y dy equals 1 minus x dx. Well, we should be able to do the antiderivative of this, right? What is the antiderivative of the right side? That's the easy side. Antiderivative of 1 is x minus 1 half x squared, or x squared over 2, that's the way I'm going to write it. You're right, Matt. Plus c. We'll leave the c on this side, okay? What's the antiderivative of 1 over y?
Well, y negative 1.
Yeah, that's y negative 1.
Y minus 2.
No. We just learned this yesterday.
Oh,
ln y. You add 1 to negative 1, you get 0. So ask what follows. ln y. All right. So now I can plug in when x is 0, y is 2. ln 2 equals 0 minus 0 plus c. So what's c? ln 2. Not 2, ln 2. So my function is ln y equals, and I'll go with what Matt said. I'm going to put it in descending power on the other side, okay, guys? Negative 1 half x squared plus x plus ln 2. Now here's where you guys hate this. Have I solved for y yet? So we know we have some more work to do. I'm going to go 100% here so you can see what I'm doing. So we have to solve this sucker just for y. Well, do you guys agree? Again, remember, this is log e of y equals, I'm going to put all this stuff in parentheses for a reason. We'll see why in a second. You agree with that? So e to this junk equals y. So y equals e to the Now the worst part, if this was a multiple choice test, this would not be the answer in the multiple choice section. Remember, this can be written like this. And what is this? We did this yesterday. Remember from pre-calc. White house is white. This value here that I just underlined, just 2. And that's the answer. All right? And again, practice. The number one thing on, oops, not dual page, single page, 100%, sorry. The big thing here on the AP coming forward is you must separate variables. That step is imperative. That's 2 points usually out of 6. All right? Because you can't integrate to a function from a differential unless you separate y and x. Right, guys? All right. I believe that was the last one, right? All right, that's the last one for today. We're going to talk about the homework problem, which was the AP problem. Thanks for listening today. Hope you're having a good time at your thingy, the rest of the students who missed today.